All right, let's consider now another example that will require the use of 3 variables and 3 equations. And the problem is this. A paper mill makes newsprint, bond, and copy machine paper. Each ton of newsprint requires 3 tons of recycled paper and 1 ton of wood pulp. Each ton of bond paper requires 2 tons of recycled paper, 4 tons of wood pulp, and 3 tons of rags. A ton of copy machine paper requires 2 tons of recycled paper, 3 tons of wood pulp, and 2 tons of rags. And we're told that the mill has 4,200 tons of recycled paper altogether, 5,800 tons of wood pulp, and 3,900 tons of rags. And we're asked to find how much of each kind of paper can be made from these supplies. So we'll next organize the information, and I think what we'll do in this case is to organize the information into a chart for convenience. I've organized the information in a chart in this problem to make it easier to decide what equations we need to write to solve the problem. And so you can see listed off to the left here in red are the 3 types of paper: newsprint, bond, and copy machine. And across the top I've listed the supplies that are used to make each kind of paper: the recycled paper, the wood pulp, and the rags. Now we're told that for the newsprint it requires 3 tons of recycled paper and 1 ton of wood pulp and no tons of rags. For the bond paper it requires 2 tons of recycled paper, 4 tons of wood pulp, and 3 tons of rags. And the third row for the copy machine paper it requires 2 tons of recycled paper, 3 tons of wood pulp, and 2 tons of rags. Now altogether we're told that there are 4,200 tons of recycled paper, 5,800 tons of wood pulp, and 3,900 tons of rags. So now let's next define some variables and write the system of equations we need. Now as far as representing the unknown items, I've chosen to let X be the number of tons of newsprint produced, Y the number of tons of bond paper produced, and Z then the number of tons of copy machine paper produced. Now we're assuming, of course, in this problem that we're going to use all of the available supplies that are available. So that means we're going to be using all 4,200 tons of recycled paper, all 5,800 tons of the wood pulp, and all 3,900 tons of rags. So what we'll be doing then is taking the number of tons of each kind of paper, multiplying then by the number of tons required of a particular supply to produce that paper. And those then will produce the equations we need to solve the problem. So if you look at the column underneath recycled paper, hopefully it seems reasonable then that we're going to have the equation 3x plus 2y plus 2z is equal to 4,200. And if you look at the column under wood pulp, we'll then have x plus 4y plus 3z is equal to 5,800. And in the column underneath rags, we'll then have the equation 3y plus 2z is equal to 3,900. Now you notice that equation 3 contains only the variables y and z. So it should seem reasonable that our strategy will be to eliminate the x variable using equations 1 and 2, and then use that equation that results in conjunction with equation 3 to solve for y and z. So to do that, we'll first multiply equation 2 by negative 3, then add it to equation 1. So rewriting equation 1 below, right here, you can see we have 3x plus 2y plus 2z is equal to 4,200. And if we multiply equation 2 by negative 3, we'll end up then with negative 3x minus 12y minus 9z is equal to negative 17,400. So we're going to call the equation we get when we add those two together equation 4, which is negative 10y minus 7z is equal to negative 13,200. So rewriting equation 3 below that, then we can see that we have two equations involving y and z. So now we next need to tackle eliminating either the y or z term. And I think I'm going to choose to eliminate the z term. So we'll multiply equation 4 by 2 and equation 3 then by 7. So multiplying equation 4 by 2, you can see that we get negative 20y minus 14z is equal to negative 26,400. And multiplying equation 3 by 7, we end up then with 21y plus 14z is equal to 27,300. Now if we add the two equations together, we very conveniently get then that y is equal to 900. So now we next need to find the values for x and z. To find z now, we can use equation 3, which you'll see restated here is the 3y plus 2z is equal to 3,900. And we'll replace then the y with 900. And in multiplying, we end up then with 2,700 plus 2z is equal to 3,900. And subtracting 2,700 from each side, we'll have 2z is equal to 1,200, or then z is equal to 600. Now I think to find x will be easiest if we go back and use equation 2. Now equation 2 is the equation x plus 4y plus 3z is equal to 5,800. So in the equation we'll replace the y with 900 and the z with 600. Then simplifying, we have then x plus 3,600 plus 1,800 is equal to 5,800. And adding the constants, we end up then with x plus 5,400 is equal to 5,800, or then x is equal to 400. So what we'll do next then is to write a sentence answering the question posed by the problem. So we can state then that there will be 400 tons of newsprint produced, 900 tons of bond paper produced, and 600 tons of copy machine paper produced. And as always, it's a good idea to go through the check. So if you substitute those values into each of the three equations, I'll leave it to you to actually carry out the computation here. But I think you will find, hopefully, that all of the values check in each equation.